Question number 5. Define alternating current. So alternating current AC. So if you define to alternating current, you can compare to the DC current. If there's DC current, let's say you have the battery, and this is positive, this is negative, so meaning the current flow from positive to negative. But if you have a AC current or alternating current, so this is symbol for the DC. So for the AC, you must use the symbol for the AC. This is symbol for the AC. And so the first is this is positive, this is negative. So meaning the current flow from positive to negative. So after that, this is positive, this is negative. So the second round, this have a direction of the current flow. So meaning the current flow is the first part is a direction to the from the left to the right, and the second part is to the right to the left. So alternating current is that alternate or change its direction at a regular interval or time t, right? So this is a direction change, and this is a fixed direction. So this is how you can define the electric current. So next question number 5b. A 3 kilo ohm resistor, this is R, and this is inductor. Okay, inductor reactance 4.7 kilo ohm. So this is a XL, right? Inductor reactance, and this is a 12 volt supply, meaning for the AC here. So this is a V RMS. So number 1 is calculate the impedance. So for the impedance Z, you can use the equation R square plus XL square. R square is equal to 3 kilo is times 10 power of 3, and the XL is equal to 4.7 kilo is times 10 power of 3. So you can find the impedance here is equal to 5.58 kilo ohm. Number 2, find the RMS current. So for RMS current, you can relate your use equation VRMS is equal to IRMS times Z or impedance. So from the information given by the equation, VRMS is equal to 12, and the Z impedance is come from the answer number 1 is 5.58 exponent 3 kilo, right? Kilo ohm. So you can find the IRMS is equal to 2.15 exponent minus 3 ampere. Okay, next, sketch Paso diagram across resistor and inductor VL and the supply voltage V. So now this is a R L circuit, right? So meaning you have in the circuit you have a resistor and you have a inductor L. So for Paso diagram for this circuit or RL circuit is a VL leads VR with a 90 degree, and this is a resultant of V for the voltage, right? So continue number 5C. An electric motor is connected to the 230 volt. So if the question give you the value of the AC current, and this is a voltage, meaning this is a V RMS, right? So this is a frequency, and the motor has resistor 15 ohm, so this is R, and inductive reactance is 27 ohm, so this is XL. So number 1, what is the power factor? So to calculate the power factor, you can use the equation. So power factor is given by the equation of cos psi is equal to R over impedance X. So now the R can use the 15 ohm. Z, so for the Z here, you can use the equation to calculate the impedance is R square, because this is a RL circuit, meaning you have R resistor and inductor L. So meaning you have R square plus, XL square. R is equal to 50 ohm and the XL is equal to 27. So if you use the calculator, the value of the Z here is equal to 27 square. So this is 30.89 ohm. So you can use the equation, so the value of the Z to the equation here, so you can find the power factor is equal to 0.486. Number 2, average power. So average power, you can use the equation, or the P average is equal to I RMS times V RMS, okay, power factor, and the I RMS here. So what is I RMS? If you look at the information here, so you don't have the value of the I, so meaning you can, first you must know the value of the I RMS. So because you can use the equation, V RMS is equal to I RMS times Z. So I RMS is equal to V RMS divided by impedance Z, and the value of the V RMS is equal to 230, and the Z is come from the answer number 1. Calculation number 1 is 30.89, and you can find the value of RMS. So V RMS come from the question 230, and the power factor cosine is equal to 0.486. So the final answer, power average, is equal to 832 watt. And number 3, the value of the capacitor to be added in the series with the motor so that the power factor is equal to 1. So power factor is equal to 1, meaning the value of the cos phi is equal to 1. So if you look at the equation, so I write here, right? So when the cos power factor is equal to 1, because power factor is equal to cosine is equal to R over Z, right? So meaning here, the value of the R over Z must is equal to 1. So meaning R must is equal to Z here, right? But from the equation, impedance Z, right, is equal to resistor square plus XL minus XC square. So meaning to find the value of the power factor or cosine is equal to 1, meaning the XL minus XC is equal to 0. So meaning here Z is equal to R. When Z is equal to R here, so power factor is equal to 1. So power factor equal to 1 happen when the XC is equal to XL, right? So XC here, so right there, and so the XC here is equal to 1 over 2 pi FC, and XL here is 2 pi FL. So meaning you can use the equation, the frequency here is equal to 15 Hertz. So this is 50, this is 50, and the pi, 2 pi is constant, and the L is a this is inductive reactance, right? So maybe because the question gives you the value of the inductive reactance, okay, XC is equal to XL, because inductive reactance is equal to 27, so XC is equal to 1 over 2 pi FC Now you can use the frequency is 50 Hz, and you can find the capacitance of the capacitor to be added in series, so that motor, the power factor is equal to 1. So you can find the equation, use the equation here. So the C is equal to 1.18 exponent minus 4 farad. Thank you.